Salam and welcome everyone. So today we're going to be working on the question on the screen that says, to what speed must an electron be accelerated for it to have a de Broglie wavelength of 3.0 centimeters? I wanted to first of all say that this is a question from the Physical Chemistry Atkins 11th edition textbook, and we're dealing with chapter 7 called quantum theory. So this question is saying that we must find the speed of an electron that will be needed for it to be accelerated whenever we have a de Broglie wavelength of 3.0 centimeter. So basically, the solution would be for us to first of all write out the parameters. We are asked to solve for the velocity, so the speed, and we are told the wavelength, which is just 3.0 centimeter, or we can write the wavelength in terms of meter. So we have the wavelength is 3.0 times 10 raised to the power of negative 2 meters. So that is basically it. Now, I wanted to say that the main keyword here in this question is the de Broglie wavelength. If you're studying chapter 7A of the textbook, you're going to notice that there is a formula called de Broglie relation formula, and the de Broglie and the de Broglie relation formula is wavelength is equal to h, which is Planck's constant, divided by p. So h is equal to Planck's constant, okay, and then p is equal to the linear momentum. And of course, the lambda is the wavelength. So you're going to be wondering, well, naturally, we already know Planck constant is a constant, so we always know the value. And the value for Planck's constant H is just 6.626 times 10 raised to the power of negative 34 joules seconds. So you might be wondering, well, we have H, we have lambda, and we can easily solve P. But then there's an issue. And the issue is that when we find P, we're going to be wondering, well, P linear momentum, we're not asked to find linear momentum. Instead, we're asked to find the value of B. Now, I want to give you a quick reminder that P, which is linear momentum, is just simply the mass times velocity. So if you go back to your elementary physics in high school, or even some of the elementary physics you did in college, you're going to remember as a science student that linear momentum is always equal to mass times velocity. That is linear momentum. Mass times what? Velocity. So if it is equal to mass times velocity, we can just simply substitute. And the new formula we're going to use is going to be lambda is equal to h divided by mv. So lambda is equal to Planck's constant divided by mass times velocity. So we can now rewrite this equation in terms of v velocity. We're going to rewrite this equation in terms of velocity. So it's going to end up being lambda times m times v is equals to h, right? And velocity is now going to equal h divided by lambda times mass. Okay, so that is basically the formula we're going to use. So now we know what the Planck's constant is equal to. We know what the value for wavelength is equal to. The Planck's constant 6.626 times 10 to the power of negative 34 joule seconds. We know what the lambda, what the wavelength is equal to, but we don't know what the mass is. But then when we go back to the question, we were told that we're dealing with an electron. To what speed must an electron be accelerated? So for those of you who don't know, if you go to the back of your textbook or if you've done Gen Chem, you will know that we have the mass of electron, and the mass of electron is just simply, okay, mass of electron, just Me, is just simply 9.1094 times 10 raised to the power of negative 31 kilograms. So that is the mass. That's the mass of electron. So Me is mass of electron. So we can rewrite the formula again to be H divided by lambda Me. So now we just simply substitute. So velocity is just simply plus constant 6.626 times 10 raised to the power of negative 34 joule seconds divided by lambda, which is just simply 3.0 times 10 raised to the power of negative 2 meters, okay, times the mass of electron, which is just simply 9.1094 times 10 raised to the power of negative 31 kilogram. So that is that. That is basically that. Now, I want to really mention something again. We see now that in our sciences, we know we are always supposed to be canceling stuff out. We have joules, we have seconds, we have kilograms, we have mass. And you're going to be wondering, there's nothing that can be cancelled here. So what is up? Well, let's not forget that the units for joules, okay, is simply The unit for joules is actually kilogram meter square per second square. And the reason is because joules is just energy, okay? It is the unit of energy. And energy is equal to basically energy is simply equal to force times distance, okay? And we know force to equal mass times acceleration. So mass times acceleration times um, displacement or distance is what energy is actually equal to. So energy is equal to mass times acceleration times distance. The unit for mass is just kilograms. Unit for acceleration is what meter per second. Unit for distance, SI unit is second. So acceleration, sorry, meter per second squared. And then distance, the unit for distance is just simply meters as well. So unit for mass, kilogram, unit for acceleration, meter per second square, unit for distance is what's meter. So everything will end up becoming kilogram, meter square per second square. So that is basically the unit. So knowing that knowledge, we know that this is just the same thing as joules. So that is what we're going to instead, that's what we're going to input here. So let me just erase all of this. And we need all of that, all this information in order for us to, basically stick to what we're supposed to do. So I'm just going to rewrite what is at the top with the proper SI units. So that will be V is equal to 6.626 times 10 raised to the power of negative 34 joule second. Okay, it's no longer joule second anymore. It's going to be kilogram meter square divided by second square. Let's not forget that Planck's constant is joule seconds. So we still have this seconds right here. So we're just going to put second. Okay, because that's the other part of it. So all of this divided by 3.0 times 10 raised to the power of negative 2 meters times 9.0 times 10 raised to the power of negative 31 kilogram. So you divide kilogram here, divide kilogram here, divide meter here, divide meter here, divide second here, divide second here. So velocity ends up becoming meter per second. So let's just put this in a calculator. 6.626 times 10 to the power of negative 34 divided by 3.0 times 10 to the power of negative 2 divided by 9.1094 times 10 to the power of negative 31. When you input that information in the calculator, you end up with 2.4246 times 10 raised to the power of negative 2 meter per second. So again, let's go back to our question. When we go back to our question, we can put in the proper number of sig figs. So it's going to be 2 sig figs. So velocity ends up becoming 2.4 times 10 raised to the power of negative 2 meter per second. So that is basically the answer to this question. If you have any questions, please put it in the comment section. If you have any suggestions and concerns of how to improve the channel or just your own observations, please also put it in the comment section. If you're a student who's struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I'm the tutor for you. I help students excel in academia relating to their STEM courses by my way of tutoring and mentorship. So if you would like to book a session with me, please email me at shahabi tutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.